Welcome back to part 3 for topic 10 for Algebra 2 on piecewise functions. In this video, we're going to learn how to graph a piecewise function as well as how to write a piecewise function if we're given a graph. So first, let's practice graphing a piecewise function. In this example, we have h of x equals 3/4 x minus 1 if x is less than 0, and negative 2x plus 1 if x is greater than or equal to 0. So what I like to do first is I like to look here at my x values. This is kind of like my domain where I'm going to be starting and stopping. And I like to draw a line. It just happens that this is right on the y-axis. So when x is less than 0, I'm going to use this top function. So I can graph this. 3/4 x minus 1. Now because this is a less than sign, think back to when we were graphing inequalities on a number line. We're going to have an open circle. So I'm going to just graph this line, but I'm not going to go to the right of the y-axis, only to the left because x is less than 0. So again, just like how I'd normally graph a line, I'm going to start with my y-intercept, and I have an open circle right here. Now my slope is positive 3/4. I can also extend that. That is the same thing. Positive 3/4 is the same thing as negative 3 over negative 4. Remember, because a negative divided by a negative is a positive. So instead of going up 3 and to the right 4, I can go down 3 and to the left 4. Extending it in the opposite direction. Goes a little bit off the grid, but there we go. So that is my first graph. Now, when x is greater than or equal to 0, I have negative 2x plus 1. Now, because this is greater than or equal to, we're going to have a closed circle. Okay, so just like we'd be graphing normally, except we're going to graph on the right-hand side of our y-axis. So we're only going to graph on the positive x values. So we have a closed circle at 1, and our slope here is negative 2, or negative 2 over 1. So we can go down 2 to the right 1, down 2 to the right 1. So we have a negative slope. And there's our graph right there. Feel free to, if you want to, keep kind of like your boundary lines up for when you need to separate in between your functions or when you need to see like a distinction in between them. But you can also erase it afterwards if that's helpful. Let's do another example. So this one we have 3. So y equals 2 if x is less than negative 3. X minus 2 if negative 3 is less than or equal to x, which is less than 4. And if negative 1/2 x plus 4 if x is greater than or equal to 4. So right now I have like 2 boundary lines. I'm going to have one at negative 3 and one at positive 4. There we go. Okay, so if I have my first one, when x is less than negative 3. Again, since x is less than negative 3, we're going to have an open circle. Now this is really, remember, this is y equals all of those values. So this is y equals 2. This is really just, a horizontal line with an open circle. So horizontal line, y equals 2. So if we wanted to start kind of where y equals 2, it would be right here and it would go all the way. However, this is only when x is less than negative 3. So we're not going to, actually our line would go all the way across, but we're not going to have it go all the way across. We're just going to have it start at that line and go over. There we go. So this is at the line at y equals 2, so where it would cross the y-axis at 2. Then we can move on. So in between -3 is less than or equal to x, which is less than 4, we have x minus 2. So this is where we have another line. Let's do this one in green. Okay, so if we have x minus 2, our y-intercept is 2. This is really handy because it is on this graph will fit actually on our y-axis, so we don't need to kind of like estimate or sketch over the boundary line just to kind of identify where it should cross. And then our slope is really 1 over 1. So we can rise 1, run 1, rise 1, run, rise 1, run, rise 1, run. Now notice here we have a strictly less than, so this is going to be an open circle on that boundary line, but this one right here is a closed circle. So if we extend our graph in the opposite direction, we're going to have a closed circle there. There we go. Now our final graph, we have -1/2 x plus 4. So this is where it's a little tricky because this section of the graph does not include the y-axis, so it's a little bit more difficult to determine what the y-intercept is. But it's plus 4. So what I like to do is just sketch it and then end up erasing it over that portion. So let's say it was over here. Then it would be right here, and my slope is -1/2, so I'm going to go over down 1 to the right 2, down 1 to the right 2. Notice here how now that was an open circle, it's going to be filled because this says x is greater than or equal to 4, so we're going to have a closed circle. So it actually fills it in. Down 1 to the right 2, down 1 to the right 2. And we only need to draw our line from +4 over to the right. So these other points that we plotted, we don't need them. All done. So you can erase those. And then if we take away our boundary lines, here we go. Here's our piecewise function. So what if you are given a graph and you're asked to work backwards and you're asked to write the piecewise function depicted below? So again, what I like to do is just draw my kind of boundary line. So we can tell this is at 2. So if we have our graph on the left-hand side, let's do it in blue, on the left-hand side, and this has an open circle, and we're moving to the left, so that means it has to be when x is less than 2, because we're covering all of these values that are smaller than +2. Then we can determine the graph of this line. So our y-intercept right here is -1, and our slope, we count up 1 to the left 2, up 1 to the left 2. So this is a negative slope, this is going to be -1/2 x. If we move on to our other graph, this has a closed circle. And we know that we're moving to the right, so things that are bigger than 2. So this is x is greater than or equal to 2. Now at this line, we can determine the slope based off this because we are rising 1, running 1. So this is going to be 1x or just x, but it's a little bit more difficult to determine what the y-intercept is. So once we know our slope, we can extend our line, and we actually can see that our y-intercept would be the same for both of them, -1. So let's call this g of x. Change it up a bit. So g of x is -1/2 x minus 1 when x is less than 2, and x minus 1 when x is greater than or equal to 2.